Hello and welcome to this short video about 4x4 MIMO and the benefits of 4 transmit paths at base station side and 4 receive paths in the smartphones on the average capacity. I'm Arnd Sibila and I'm working as Technology Marketing Manager at Rohde and Schwarz with focus on mobile network testing. Why the topic is important, why we are talking about it. We all know the exploding data demand in mobile networks and that capacity expansion is a must for mobile network operators. One promising capacity optimization feature is in macro networks is 4x4 MIMO, where even higher data rates can be transmitted over the same radio resources. So let's jump directly into the theory of 4x4 MIMO. So we see on the slide on the left side the base station with its 4 transmit antennas, and you see the UE, the smartphone, with 4 receive antennas. And you see the linear equation set up here with the H matrix, colored in red now. And only by matrix transformation, which is called singular value decomposition, we can generate a matrix that only consists of the singular values, the sigmas, and all the other values in the matrix are 0. Singular value, the sigmas you see here are the singular values of the matrix. Now we talk about two very important topics, the rank and the condition number. The rank is the number of non-zero singular values, so non-zero sigmas, and this gives us the number of possible MIMO streams. So in a 4x4 MIMO system it can be maximum 4 or even less. The condition number is basically the division by the maximum sigma divided by the minimum sigma, and this is suited. This defines how suited the channel is for MIMO, how easy the receiver can solve these linear equations. If the condition number is, if all zeros are equal, the condition number is 1 or 0 dB. We have a perfect MIMO channel and the receiver can solve the linear equation very easily. Yeah. If the condition number is around 20 dB, so we have a big imbalance in the different multipaths, we have a very bad MIMO channel. That means the receiver cannot really solve the equation easily. And a higher signal-to-noise ratio would be needed in these environments. How can we test this? A best test and measurement solution for testing MIMO is using unmodified smartphones. And these are available nowadays for 2x2 MIMO, 2x2 MIMO concepts here. To get the rank and the condition number, to measure the rank and the condition number, we are using network scanners. In LTE, for example, you see here a screenshot showing a waterfall diagram over a 10 megahertz carrier. So you see 50 resource blocks here, and in the middle you see a green area. The green area indicates a very low condition number. So this part in the spectrum is very useful for 2x2 MIMO. So low values for the condition number means we have a well-conditioned setup, and this is suitable for 2x2 MIMO. Nowadays we are talking about 4x4 MIMO, and here the solution is also available. We have the ROMUS software for network optimization and troubleshooting, and we have 4 scanners, 4 TSMEs in this example, and we of course need to use 4 receive antenna. The suitable picture here for 4x4 MIMO, you see the 16 H matrix components, and you see in red color here the condition number again, and you see in the waterfall diagram that this 4x4 multipath environment is more critical, and in this setup the use of 4x4 MIMO would not be recommended. But this is exactly the reason, the justification. We want to measure the environment in which 4x4 MIMO is suitable in mobile networks. And this is not for rural areas or suburban areas, but this is more or less for dense urban areas where we have a lot of multipath environments. What is the status of the ecosystem, the device status? We have currently not many smartphones supporting 4x4 MIMO. And this is the last status we have here, January 2017. We have 3 devices, and mostly they are operator-specific devices. We see 2 Samsung phones here for the T-Mobile US 4x4 MIMO networks, and we have a Sony mobile smartphone here, also for a dedicated customer. So the smartphone manufacturers are still hesitant to promote 4x4 MIMO because it's very difficult in a smartphone form factor to generate 4 uncorrelated receive paths. and the antenna, 4 uncorrelated antennas in the device. This is very difficult, and the processor, here the Snapdragon 820 for example with the X212 LTE modem is just the data processing precondition, but the antenna design is the limiting factor. The Mobile World Congress 2017 in Barcelona shows another newcomer here, Sony Mobile XZ Premium. This supports 4x4 MIMO now as well. So we expect that this 4x4 MIMO ecosystem will grow and grow as the time passes. So what is the real gain of 4x4 MIMO? What is the gain potential? And here we see a picture that has been made by cellularinsights.com, where you see in a controlled lab environment, you have a smartphone in a shielded box, and you have a test setup where you can control the coverage value, so the RSRP, the receive signal reference power here in dBm. And this is a curve for Samsung Galaxy S7 Edge, the T-Mobile US variant. And you see the theoretical case of 300 megabit per second data throughput for 4x4 MIMO using a 20 megahertz carrier. So this is the maximum that you can achieve theoretically. And you see from minus 100 dBm downwards, you see the curve is going down. But what is very important is that you see also quite high values for very low coverage values. So first of all, the 4x4 MIMO gain is on the left side of the graph, where you really have these high peak throughputs by using 4 different signals that are transmitted by the base station and received in good conditions by the smartphone. But again, you see as well here the right part of this graph here, and this shows more or less the 4x2 MIMO gains. So we have a superior throughput at the cell edge as well, because we are using 4 transmitters on the base station side, and we can use transmit diversity. So we use 2 signals that are transmitted by 2 antennas each by the base station. And on the receive side, on the UE side, we have also receive diversity. So we receive 2 different signals by 2 antennas each, and this gives us a certain gain, and this is very important in particular for the performance at the cell edge. In the T-Mobile US network, in the live T-Mobile US network for 4x4 MIMO, there were also tests has been done, and they showed a speed improvement around 55% here, comparing a 4x4 MIMO device compared to a 2x2 MIMO device. So this is the same message here. It's not only for peak data rates, but is as well good for the performance at the cell edge. So the gain in mobile network can only achieve if the penetration of 4x4 MIMO capable devices is higher, and the higher the number of such devices in the network is, the stronger is the gain in network capacity for the mobile network operators. A little bit about the market info and as well about test solutions here. Currently, we see that every operator in the world is really interested in 4x4 MIMO because it increases, of course, the data throughput close to the base station, but as well towards the cell edge. Many operators testing it already in test networks. Vodafone Germany, for example, is just one example. There are others as well. And some operators even launched it. Yeah, so some with a lot of noise. So we have T-Mobile US is is marketing 4x4 MIMO very highly, very severely here. So what are the test solutions here? We have to measure 4x4 MIMO. We have the scanner solution, scanners set up. So we have 4 one-channel scanners here, TSMEs, connected to the Rohde software platform for network optimization and troubleshooting. And we have also here a backpack solution where the 4 scanners and a PC and also a smartphone can be installed, can be commissioned here in a backpack solution for walk tests. And we have our QualiPOC Android software here because we are also trying, of course, to get always the newest devices and to integrate our QualiPOC Android software on the newest devices, even making use out of 4x4 MIMO. Thank you for your time today. I hope I could convince you about the advantages of 4x4 MIMO and about the advantage of the 4 receive paths in smartphones, in peak as well as in cell edge data throughput. If you want to know more about test solutions, please follow the link on the following slide.